All right, this video is for the 4.8 homework, but we're going to look at the calculator tip first. So what we're doing today is trend lines. So again, that's working with real world data that doesn't graph in this nice pretty straight line like we've been dealing with. Real world data rarely lines up like that. And so typically it's a little bit scattered, but you can kind of see the pattern. But we can use that data, and that data is used a lot in the real world, to calculate different amounts. So especially if you're trying to figure out how many pink sweatshirts do I need to buy this year? Like if you own a store or something like that, you can use the data and you can make a good estimate. And so that's what we're going to do. With this calculator tip, we're going to estimate values from a line of best fit. So the table below shows the data for number of hours spent studying versus the score a student makes on a test. A linear function can be used to model the data. Based on the data, what is the best prediction of the score a student would make on a test if they studied for 2.5 hours? So you could kind of best guess. So like here's 2 and 3, 75 and 84. We know it's going to be somewhere between 75 and 84. But look at our answer choices. That's a hard pick. It's not like our answer choices are 80 or 60 where they're real spread. And this is how they show up on the EOC. I don't agree with it that they put those values so close, but that's what they do. So what we're going to do is we're going to put this in a table in the calculator. So in your calculator, what you can do, so same way that like we do linear regression and all that stuff, we're going to put this data in a table. Make sure everything matches up. Make sure you get the right values in. It's really easy to accidentally push the wrong button, put a wrong number in. But what we're going to do is we're actually going to do linear regression on this. Menu 4, 1, 3. X list, Y list. And it's going to give me an equation. Again, real world equations are not nice and pretty. They're big, long, ugly decimals. Okay? But what we can do, and this is the cool thing with your calculators, once you run linear regression, you can press home and then this graph button here, and then you do up. So it says F2 here, so we know we're in the second line. So if you press the up key, it takes you back up to the first line, and it fills in that equation that the linear regression calculated. So you don't have to type in all those gross numbers. It does it for you. And if you push enter, it graphs it for you. So I'm going to zoom out, menu 4, 4, so we can see it a little bit better. And so now I'm on the other side of this page. Let me move around here. And so that's what we just did here. Here's the keys for how I did that. Here's how I zoomed out. So we're looking for 2.5 hours. 2.5 is an X value, okay? So in my calculator, once I have the graph up, I can press menu 5, 1, and I can type in any X value. The X value I want is 2.5. And it will find that point on that graph. And then down here in the corner, it puts the Y value that's associated with that. And that's what we're looking for. We're looking for the grade that's associated with studying for 2.5 hours. And it's 79. And so doing it that way helps you narrow down when those values they give you are so close, which one should I pick? So that is a really handy tool. I don't know, we're probably not going to do a quiz over this stuff because we got replace it grades tomorrow, and then Friday's going to be wonky. So we probably won't do a quiz over this material that we're about to cover. So good news. All right, so on to the actual page for today. So number 1, what is the name of a line on a scatter plot that helps show the correlation between data sets more clearly? This is a trend line. And that's what's drawn on these graphs. Those are all trend lines on scatter plots. And then number 2, what is the name of closely grouped data? It's a cluster. And again, in the real world, those clusters are used in shopping, in the shopping industry, in the fashion industry, in the sports industry, in any type of manufacturing, anything like that. Those clusters tell you what people want or what people can do, what they're good at. All right. So this whole section goes together. So it says draw a trend line on the scatter plot, then answer the following questions. So when we draw a trend line, especially through real world data, we want to do our best to get it in the middle of the data. We don't play connect the dots, so we're not, connecting the dots. What we want is about the same number of points above the line as are below the line. Okay? Everybody's trend line is going to be different. Okay, but the goal is to try to get it in the middle. So like here, I've got one, kind of 2 dots above, and then I've got 3 dots below my line. That's pretty close. And then we can use this to make predictions. So number 4, based on the scatter plot, what's the best estimate of the time it takes to travel 1.5 miles? So here's miles. So I'm going to go to where 1.5 is. So that's kind of halfway in between 1 and 2. And I'm going to draw a line straight up to my trend line. And then when I hit my trend line, I'm going to make a left turn. And where I fall is about my answer. So I'm in between 10 and 20. I'd say I'm not halfway. So I'm not quite at 15. So for this one, I put about 12 minutes. Here's how I grade stuff like this. Since I'm halfway in between 10 and 20, I would take any answer, probably 11, 12, 13, 14, 15. I'm not expecting you to guess the exact same number I did. And again, all of our trend lines are going to be different. I'm going to do this 3 more times today, and I guarantee you it's going to be different every single time. Okay? So I grade based on, did you draw the trend line, and did you follow the path to find your answer? Did you use your information? All right, based on the scatter plot, what's the best estimate of the distance traveled in 50 minutes? So minutes is over here. So I'm going to go to the 50, start there, and I'm going to follow it across to the graph. And then once I hit my trend line, I'm going to go straight down. So here, I'm in between 4 and 5. I'm closer to 5. So for this one, I put about 4.7 miles. And again, 4.5, 4.6, 4.7, any of those. And then finally, based on the scatter plot, what is the best estimate of the time it takes to travel 6 miles? So again, we're back here. Watch your labels. Make sure you're on the right axis. So here's 6 miles. And now this is what's called extrapolating information. So the information that we've done here on these two, this is called interpolation. It falls within the data we're given. Extrapolation is when you're guessing a number that falls outside the data set that you're giving. So this one is almost to the top of my line. And if I go across, I'm way above 60. So about 65 minutes. With extrapolation especially, the best thing you can do is that calculator tip that I showed you. If they give you a table, do that. It's kind of hard to do it off of here, guessing the values of the points. Okay. So down at the bottom, we're going to write the equation, slope-intercept form, so the easy form, of each trend line using the points given. So the points given are the bigger dots on each graph. Okay, so you can kind of see them. They're a different color and they're bigger than the other dots. So what we have to do is we have to write the ordered pairs for those dots. So this point here is at 5, 7. This point here is at 15, 0. And all this is linear regression. Okay. This is why it's important that you know how to do linear regression. So remember with ordered pairs, if you're struggling to get pieces in the right places, stack them up, draw a line through your commas. This is X, this is Y. And that's where your pieces should be. So 5 and 15, and then 7 and 0. Menu 4, 1, 3. Change the X list to X, the Y list to Y. And we get decimals. So for my M, I got negative 0.7, and for B, I got 10.5. We're going to change those to fractions. So I'm going to go to a calculator page, negative 0.7, menu 22, and there's my slope, negative 7/10. X goes behind my slope, and then I've got 10.5, menu 22, and I get 21 over 2. With real world data like this, typically I would let you leave it as decimals, but you guys are still struggling to put things in fraction form, so that's why we're going to stick it into fraction form on here. All right, so on number 9, my points. This point is at 20,2. This point is at 80,10. 80,10. So I'm going to do linear regression again. Okay. Oop, X out. Remember, always start fresh with linear regression. All right, so 20 and 80, 2 and 10, menu 4, 1, 3. Change the X list to X, the Y list to Y. And now I got some gross numbers. So my slope here is 0.13 repeating. My B value is negative 0.6 repeating. So I need to change it to decimals. So 0.1, it's the 3 that repeats. So I got to make sure that I put that 1 in there. But the 3 is what happens multiple times. Menu 2, and I get 2/15. So that's my slope. And then negative 0.6, and the 6 is what's repeating. Remember, your calculator likes to round things off. I'll show you what I mean in a second. So minus 2/3. So on that y-intercept, if you go to this box, you see how it's got that 7 at the end? Don't put that 7. That's your calculator rounding it off to make it fit in the space. Okay? So all you have on this page are 2 questions. Okay? Write the ordered pairs, do linear regression. Everything needs to be in fraction form.